Hello everyone, welcome back. In this tutorial, we will talk about the concurrency model in Ballerina. And later in this tutorial, we will try to use some concurrency constructs in our social media service. Ballerina concurrency is built on the concept of strands. A strand is a lightweight thread. A Ballerina program can execute by using one or more physical threads. One thread can have one or more strands. A strand is executed by using a thread. At a given time, one thread can execute only one strand. In Ballerina, there are a couple of ways to create a new strand. The first way to create a strand in Ballerina is by using the start action. If we go to this example, inside the main function, we are calling another function foo by using this start action. When we call a function using this start action, it will create another strand and execute this function inside that strand. The start action will return a future, which contains the return value of the function. If we want to get the return value of the function, we can use the wait action on the returned future. The wait action will return the expected return value, or else it will return an error. The second way of creating a new strand in Ballerina is by using named workers. Normally, a function's code is executed by using the default worker which is assigned to the function. The default worker will have one strand. And from within the function, we can declare multiple named workers. In this main function, we have declared two named workers. A named worker can be declared by using worker keyword followed by the worker name, and then within the braces, we can provide the code which the worker should execute. Whenever we declare a worker, it will create a new strand and execute this code using that strand. When discussing about the workers, it is important to know how we can pass values to these workers. All the variables declared before the worker declaration and all the input parameters to this function are visible from within this worker. And it is important to notice that the code which is declared before this worker will be executed before we start this worker. In concurrent programming, it is important to know how we can share the state among multiple strands. If we want to share a mutable state among multiple strands, we can use the lock state. In this example, we have defined an integer n as a global variable, and from within this function, we are trying to increment it. We have defined this increment operation within a lock statement. The lock statement acts as an atomic section. So whatever we put inside this lock statement will be executed together. If we want to share immutable state among multiple strands, we can use read-only type. In this particular program, first we have defined a constant s with a value. In Ballerina, constants are immutable. The second way of defining a read-only object or a read-only value is by using read-only keyword. In this example, the raw record has a field k which has a type string and read-only. That means once we assign a value to k, it can never be changed. Both the field and the value are immutable. Let's say we want to mark all the fields in this record as immutable. One way to do this is by marking every field with read-only keyword. Another quick and efficient way to do this is by adding read-only to the record definition. Once we have a read-only or an immutable value, it can be shared among multiple strands without using the lock keyword. Now we have learned basic concurrency constructs in Ballerina. Let's see how we can use that knowledge in our social media service. In my previous tutorial, we discussed how to implement the functionality to send a message to a Slack channel whenever a user creates a new post in the system. For simplicity, I have extracted out the functionality to send the message into a different function, and I am calling this function from within the original resource. When a user sends a request for this particular resource, it has to wait until all these actions are completed to get a response. Here, the publish Slack notification action is not need to be executed sequentially as the other actions. It can be executed asynchronously. For that, we can use the start keyword. When we use the start keyword, this publish Slack notification action will be executed in a different strand. That means the original resource can complete successfully without waiting for this publish Slack notification action to be completed. When we use the start keyword, it will return a future with the return value of the function we have just called. But here we are not interested in the future which is returned by the start keyword. So we can just ignore that. Okay. Now the publish notification action will execute asynchronously, and this resource function can respond to the user while this action is executed. Let's run and test our service. The social media service is up and running. Let's try to create a new post and see what happens. The post was created successfully. Let's see whether the Slack channel has got its notification. As you can see, the Slack channel has got the notification. So the social media service is working as expected. That is all for this session. See you in the next one.